Hello everyone, I hope you all are doing well. As you all know that I am going to start free math lessons on Zoom, so you all need to send me the topic of your interest through an email ID by 31st July of 2025, and I will revert back on the same email ID for the timings. Please send me the topic on as soon as possible because I will choose the topics, let's say 4 topics on first come first serve basis. Now this is the time for our today's video. So in this video we are gonna discuss about a very important circle theorem which says that opposite angles in a cyclic quadrilateral add up to 180 degrees. The first thing which we need to focus on here is what is a cyclic quadrilateral. So a cyclic quadrilateral is a quadrilateral whose vertices are on the circumference of the circle. So if we look at this diagram here, we have a circle and we have this quadrilateral. A quadrilateral is a polygon with 4 sides, and if you look at the 4 vertices of this quadrilateral, they are lying on the circumference of this circle. So this is called a cyclic quadrilateral. Now let's test this thing. We have given here one circle with a quadrilateral inside it, and we can see the 3 vertices of this quadrilateral are on the circumference, but the 4th one is inside the circle at the center. So is this a cyclic quadrilateral? No, this is not a cyclic quadrilateral, because for this quadrilateral to become a cyclic quadrilateral, this 4th vertex should also be somewhere on the circumference of the circle. Now we have the next part of our video, which is the opposite angles in a cyclic quadrilateral add up to 180 degrees. So we have to prove this theorem. While proving this theorem, we will be using another theorem which says that if you have a circle and the angle which is made by a chord, let's say this is a chord, the angle made by this chord at the center and the angle made by the same chord at any other point on this circle, they are related. How? If this angle is x, then this angle will be twice of x. So this relation we have to consider in order to prove this cyclic quadrilateral theorem. So for proving this theorem, what we need to have, we should be given a cyclic quadrilateral. So here is our cyclic quadrilateral, and I am going to give it the vertices the name. So we can say this is, let's say, A, this is point B, this is point C, and this is point D. So basically what we have to prove, let's say these angles are represented by these letters as well. So we have here, we have to prove that angle A plus angle C, that is 180 degrees, and similarly angle D plus angle B, that is also equal to 180 degree. Now what I am gonna do, I will be taking a point which is the center of this circle, and I am gonna join these 2 points here. Now what I am gonna do, let's say this angle is x. So if this angle is x and let's say this angle is y, so basically I have to prove that angle x plus angle y, this is equal to 180 degrees. Now what I do, this angle here, it is given as angle x, then the angle which is made here, this will be twice of this angle x, so this will be angle 2x. Similarly, if I am considering that this angle is y, so the angle made opposite to this chord, like let's say this is the chord, or let's say this is the 2 sides here, these are the 2 chords, they are making an angle of y here, and opposite to that at the center the angle made will be 2y. Correct? We are using that theorem that the angle made by the chord at the center and angle made at the circumference through the same chord, we are using that relation. So we got this angle is x. It is very important if you are taking this angle on the upside x here. So here at the center also you have to take the angle at the upside. Here you are taking this angle y at the downside, and here also you have to take the angle at the downside. So now if you see these two angles, if I consider this angle at a point, so I can say one thing, that angle 2x plus 2y, it is forming one circle, one full revolution. So this is equivalent to 360 degree, because this is the angle at a point. So from here, if I divide this whole equation by 2, so I will be getting x plus y equal to 360 by 2, which is 180 degrees. So we proved that angle C plus angle A, that is equal to 180 degree. But in order to prove the theorem completely, we need to show another pair of angles, which is angle D and angle B, that is also 180 degree. We have to prove it as well. Now how we will prove it? It's a very simple part. Here either you use the same theorem, or you can do it without using the same theorem even. What you need to do, you just need to see, because this is a quadrilateral, even cyclic quadrilateral or quadrilateral, it follows one property, that sum of all the four angles is equivalent to 360 degrees. So all of these angles add up to 180 degrees. Now here already we know that angle A plus angle C, this is 180 degrees. So if these two angles are 180 degree, so I can replace this by 180, and then we have plus angle B and plus angle D, and that is equivalent to 360. Sorry, here it is not 180, it is 360. All the four angles add up to 360. Now once we did that one, now what we need to prove, we have already substituted the value here 180 for angle A plus angle C. So what we are left here, that angle B plus angle D, that is equivalent to 360 minus 180, and that is going to give me 180. So this way we prove the whole theorem.